present our integrated design project titled Smart Glasses with Chatbot. Our smart glasses serve as an interactive data collection tools uniquely designed for electrical pre-installation. It could provide clients with a seamless and empowered experience, enabling them to effortlessly conduct data collection for inspection with precision. The conventional approach for the electrical inspection face a significant challenge, which is heavily depends on manual processes. This reliance on physical site inspection not only extend the overall duration of the inspection, but also introduce the delay to the process. Electricians often grapple with the complexity of managing various tools and materials, leading to potential error in data collection and analysis, thereby compromising the accuracy of the measurement and alignment. Next, I will pass to my teammate to explain the design process.
So design process is split into 4 parts, which is the chatbot, image processing, point-to-point measurement, and electrical and mechanical design of the glass frame. So the chatbot is used to prompt the user on his requirement on the electrical installation design, or the image processing, image captured by the camera, and it will process it for the initial electrical install setup and point-to-point measurement. And the point-to-point measurement is used to measure the size of the places where the user want to install his electrical installation, and the electrical and mechanical design is the glass frame and the electrical component that will mount on it. Next. So this is the mechanical design of the smart glasses, which is the glass frame, camera, and display. And this is the schematic diagram for the electrical components. So the gyro and mini LiDAR is used to do the point-to-point measurement. The microphone is used to capture the command from the users on this requirement. Or LCD display is used to display the projection. And then the external power supply is used to power all the electrical components on the smart glasses. Next, I will pass it to my next member.
All right, so for our final product, the first thing is that the chatbot will be guiding on the users on when to take images or measurements. And the chatbot output is displayed on a reflective prism with an LCD screen. So the captured image are analyzed through our image processing algorithms for electrician to access the initial electrical setup in the client's household. So the measurements are obtained using a single point LiDAR with angle orientation data. So by collecting data from a few points, we can calculate distances between each of the points. So let me illustrate the final product with an example. So if a client plans to install new appliances, the chatbot requests images or measurements of the installation location. And then the users can capture the required information by using voice commands. So the chatbot may also inquire about the client's preferred systems or budgets to ensure a smooth installation process. So finally, all the client's responses and answers for the chatbot questions will be documented, and all this data will then be saved for future reference on the electrician side. So this will ensure seamless communication and streamlines installation process in the future. All right, so now I will pass to my next member to explain the results and testing for our product.
I'm going to talk about the testing and result part. First, the chatbot will ask the user to let it know their requirement about the electrical installation as shown in figure 1. And client, as shown in figure 2, client requests chatbot to help him to capture image of the electrical panel. So according to the request, ESPCAM will take picture of the electrical panel. And as shown in figure 3, chatbot will ask user to let it know what user want to install in their house. For example, user wanted to install an aircon. Chatbot will request user to capture image of the area which wanted to install the aircon as shown in figure 4. After the area have captured, chatbot requests client to provide description of the captured image. For example, in figure 5, client wanted to install the aircon above the wardrobe. So next, after the installation area was captured, chatbot will request for room dimension as shown in figure 6. And for the dimension, there will be 3 points taken as shown in the video at the bottom of the slide. Figure 7 and 8 show the dimension result captured by the client, and the horizontal and vertical distance of the wall will be shown after the user measure the last dimension in figure 9. So according to the figure 9, chatbot requests user to let it know the capacity of the nearby power outlet or circuit breaker. So the reply from the client is saying that their house circuit breaker is 20 ampere. So lastly, based on the information provided by user, chatbot will recommend user what can be done according to their requirement. And next, we will go into our conclusion. Smart glasses can enhance the efficiency of electrical installation by reducing the time. For the traditional method, it might take longer time as it needs the electrician to be at the house to take the measurement and knowing client requirement. But with these smart glasses, chatbot can recommend what can be done in their house according to the client requirement. And that's all for our presentation. Thank you.